Let's start with a quick dive into the modern notebook interfaces, okay? And we'll show you here. I'll show you briefly the history of Jupyter notebooks, okay? And yeah, let's start with this one first, guys. Why this need of some people, to come up with this kind of interface? Yeah. First of all, let's describe this interface. The interface, as you can see an example here below, will have separate code and text blocks. Okay, the code will be used for calculations. The text, yeah, usually could have raw text or markdown. This is formatted text. Okay, markdown is a markup language code with simple characters that may be used to format the rest of the text. Okay, we'll have a bootcamp at the end of the course if you're interested more in markdown. And once you execute or once you format some text, okay, the results will be displayed right below the executed code. Yeah, we talk more about code here because text will be rendered right away, but in a different manner. Okay, it does not appear below. You'll not see for the text both the raw markdown code followed by the rendered text. Yeah, you'll see only the rendered text. You can switch between. Okay, but for the code, you usually see, as it's a case here. Yeah, in our picture, you can see the code and followed right below by the result of the execution of this code. And usually, yeah, you may get some last statement there displaying something. It's a case here. You see, we use here matplotlib or something like this, and at the end we call for the plot, for the figure, we say plot show. Okay, when you say show, yeah, the image, the chart will be displayed right below. Okay, the block code, yeah, the block code will be executed by what we call kernels. Okay, and the kernels are in different languages, Python, SQL, and so on. Definitely, if you look at this way of doing things sequentially, one by one, basically, and because you can execute all the cells top down together or one by one, and you can jump from one cell to another. Nothing will force you to execute the cells exactly one after the other. Okay, so that way of doing things is different from what you are accustomed with building a monolith application, let's say into an IDE, integrated development environment. Okay, if you're a software developer like I am and so on, you must be used with a different way of building the application all together for several files, and yes, then you launch the whole application all together, and that's it. Okay, we'll have a look at this in more detail next. But for now, let's continue. Okay. What is this for? This is more for interactive data science and data analytics. Okay. And this may use, as you can see here, multiple languages. Notebook versus traditional architecture. Look on top. On top, we have the notebook architecture. Right below, that's a traditional monolith architecture. And where is the difference? Where is the difference? Look, we both they both may use, let's say in this case, data files. Yeah, in data analytics or in data science, definitely you need some data files or database access and so on. Okay, that's on the left side. This is the input. But for notebooks, yeah, the input goes, as I said below, into code blocks in cells. Okay, cells executed where the code is executed by kernels, and you will get partial results, yeah, with the output below each cell. Yeah, you will get partial results. These partial results may be used, yeah, in other cell blocks below and so on. Okay, so you see that's an iterative process also, and that's also a top-down approach. While looking at the traditional architecture, the monolith architecture as I described it below, you get a single language usually a single language full code. Okay, yeah, this may use external libraries, external files in different other languages, but usually you get multiple files, one or multiple files in one single language. Okay, and the full code, yeah, will be executed but by an interpreter. Yeah, this could be, yeah, through a compiler, something else, an executioner, and so on. But yeah, in Python, that's an interpreter, and you get the result on screen. Okay, the Data files themselves will be considered by the interpreter all together with the code, okay, at runtime. This is what we call it. But you don't have an iterative loop here. Whatever you do next is in the result, which is displayed on screen. So the code is totally decoupled. Let's say this way, yeah, is decoupled from the end result, which is just application executed on screen. Yeah, you no longer see the code. The code has been eventually compiled, interpreted, and so on, and you see only the application. So yeah, hopefully you'll get the picture, and let's continue. Notebook interfaces timeline. Okay, this started a long time ago, actually, and not just with Jupyter notebooks. And I'll give you here some quick timeline, some quick historical context. In around 1987, yeah, long ago, so they had a mass CAD, yeah, a CAD application. By 1988, yeah, 1 year later, they came up with Wolfram Mathematica. And this is important. You'll see why I highlighted it, because basically Jupyter Notebook has been heavily inspired from Mathematica. Okay. 1992, Maple. 1995, Maxima. Yeah, some of these applications may still exist, some others don't. It's just the evolution. By 2001, okay, Fernando Perez came up with a version of Python called Interactive Python, or IPython. Okay, and the Jupyter Notebook was provided rather like an addition to IPython. IPython was the main product, you see. And we'll experience with this one, we'll execute from the command line also some IPython. It's like just like Python. If you call Python from the command line, you can get into an interactive session and type code and execute it right away. IPython function in a similar manner, except that if you type IPython, you'll see basically the blocks the way they look in Jupyter Notebook. Okay? Historically, by 2012, you see, about 10 years later, more than 10 years later, they launched a website called Wakari.io, a Jupyter Cloud Notebook service. Okay? And by 2014, okay, they came up with Jupyter Notebook, okay, which later on has been added to what they call Jupyter Project, okay, and they included other auxiliary ecosystem projects or sub-projects, and they had a next evolution of the UI itself, yeah, called Jupyter Lab. We'll look at this one, and in particular, we'll start with a detailed section about Jupyter Notebook, and then the next section will be about Jupyter Lab, and so on. By 2014, they came up with Collaboratory, and this is an early version of Google's Colab. Both Google and Amazon, they collaborated from the start with the Jupyter project. They are still major contributors to the Jupyter project, and they both come up with specific frameworks, yeah, based on Jupyter Notebook. Other people as well, yeah. So that's why you're here, because you want to find out more about this. And by 2015, you see, Anaconda came up with Anaconda Cloud. Anaconda, yeah, that's a company that came up first with a package manager called Conda. It's still very popular, a better alternative in many cases to pip. By 2017, yeah, I was mentioning Amazon. Yeah, Amazon came up with Amazon SageMaker. Okay, and today they still expose the free version called Studio Lab. Microsoft came up in the past with Azure Notebooks. And look, Azure Notebooks were just like Colab or a Studio Lab, yeah, from Amazon, but they closed it. They closed it after a while. They are no longer here. Okay. By 2019, you see, you have an explosion of other frameworks, yeah, cloud frameworks based on Jupyter Notebook, or rather Jupyter Lab. But if you look at their web UIs, they are more refined, they are enriched, many other features, many other integrations, yeah, with all sorts of databases, you name them. And I mentioned here, yeah, Neptune, Hex, DeepNote, Datalore. Yeah, we'll look into some of these in detail. And definitely you have database vendors that became aware of the power of Jupyter Notebook, and they wanted their own environment there for people to experiment directly with their data, their database tables, basically. Because some of these vendors, like Snowflake, they may have big data. And it's very important if your notebooks execute closer to where their data is.